Hello everyone and welcome you all for the today's discussion. Today we are going to discuss about kinematics of fluid and streamlines, stream function and velocity potential. These are very important terms and very useful for the fluid mechanics because kinematics fluid means a geometrical representation of fluid in a flow field. It is a geometrical means we have to find out velocity, we have to find out acceleration by using Lagrangian and Eulerian approach. And in this way, because fluid particle will change its position in a flow field with respect to time and space. So when we consider time and space consideration of the moment and position of fluid particle with respect to fixed position, then it is a Eulerian approach. When we follow the particle point by point throughout its moment, it is a Lagrangian approach. But in fluid mechanics, Eulerian approach is more convenient and best way of representing a flow phenomena of any kind of fluid flow. And in flow phenomena, in the flow field, we define position of particle with respect of the position vector, with respect of the streamlines and path lines and stream tubes and stream function and velocity potential and acceleration. All these kinds of terms we are going to discuss in kinematics of fluid. So kinematics of fluid means geometrical representation of fluid flow phenomena. Geometrical representation of flow field. Flow field means it may be a velocity field. You can define it as a velocity field, or you can define it as acceleration field in accelerated flow. And there are methods by position vector. Flow field V is a function of V, X, Y, Z and T. And acceleration is a function of U, V, W and T. And position vector are function of X, Y, Z and T. So whether it is changing with time or with changing when there is a properties are changing of the fluid properties are changing with time, then it is a unsteady flow. When fluid particles are independent of the time, then it is a steady flow. So we are going to discuss all these terms here. First most important thing that I want to discuss here is streamline, and we are going to discuss first streamline because streamlines are very important. Streamline, stream function, velocity potential, and these are very important and it is very easy also to define stream function and streamlines. Streamlines are basic of the kinematics because it is a geometrical representation of fluid phenomena defined with the help of streamline and stream function. One streamline stream function remain constant, and that is used for the drawing geometrical property of the flow phenomena. That's why streamline and stream functions are very important. So first I would like to define streamlines in a flow phenomena. What is streamline? Streamline. Because in flow phenomena, when it is a fluid, means when we talk about the fluid, it is generally we are discussing about water as a fluid, not a gas, because in fluid mechanics mainly when we call fluid, it is a water, because most of the time either water is flowing or some kind of oil is flowing through pipe from one place to another place. So mostly when we take we say it is a fluid, then it is a water. So in fluid flow phenomena, streamlines, you can't draw any line over the fluid. So it is a hypothetical line. It is a hypothetical line. Or you can say imaginary line drawn in flow phenomena, fluid flow field drawn in a flow field in such a way that tangent at any point on the line is indication of the direction of motion of the fluid particle, and also it is also define tangent will also define magnitude and direction of the velocity. That is a streamline, and these streamlines will define stream tube. So many streamlines when combined together in a three-dimensional flow field, it becomes a stream tube in a linear one-directional motion. So streamline, as we say, it is a line drawn. So this is a streamline. This is a streamline. Any tangent drawn at this point. Any tangent, suppose this is a point. We draw a tangent here, draw a tangent at here, and this is point A, and this is point B. So this tangent so direction of velocity and magnitude, direction of velocity and also magnitude at this point. Here suppose velocity v1, here velocity v2, and this is a angle theta 1, this is angle theta. So this is direction, and tangent drawn at any point will show direction and velocity, direction and magnitude at this point. So this is a concept of streamlines. There are so many streamlines. If we make a combination of these streamlines in one dimensional, and if is a cross section A1 and if is a cross section A2, so this become a stream tube. This become a stream tube combination of so many streamlines passing through these two cross section, and these are closed. This is closed boundary, this is a closed boundary, and flow is taking place along the direction along this tube. So this become stream tube. This become stream tube. This become stream tube, and this surface become a surface of the stream tube. This is a stream tube surface. So this is a concept of streamlining. When there is a flow, we can combine so many streamlines. These are hypothetical lines drawn in a flow field, and tangent at any point will show direction and magnitude of the velocity, and combining these streamlines become a stream tube. And we can apply here also law of continuity. Suppose here velocity v1, so q equal to a1 v1 equal to a2 v2. This is a concept of continuity that we are also going to discuss in kinematics of fluid. One-dimensional and three-dimensional case we will discuss. So this concept also apply for the stream tube, because across this boundary, across the surface of the stream tube, there is no flow taking place across the surface. Only combining through this surface means volume is flowing through this stream tube, not across the surface. So continuity equation will follow for incompressible flow. For incompressible flow, continuity equation will follow here for one-dimensional q equal to a1 v1 equal to a2 v2, because rho remains constant, so density remains constant during for incompressible flow. This is a concept of stream tube. Now we will discuss what is a stream tube and how we can derive streamline equation. How we derive streamline equation? This is very important, streamline equation. So first we discuss what is the streamline equation. Streamline equation. What is streamline equation? Let us draw streamline. There are three streamlines, and suppose this is a let us show direction y, x and z. Particle is at this position A. Now reaching position at B. Having three velocities along direction, this direction velocity u, this direction velocity v, and this direction velocity w. These are three velocities along three directions, because this is a three-dimensional flow field, and particle covering distance ds from A to B. So it is covering distance x direction with velocity u, and y direction with velocity v, and z direction with velocity w. Three distances are covered: dx, dy and dz. This particle is covering distance dx with velocity u, dy with velocity v, and dz with velocity w. So because r and time interval is same, in same time interval dt, this particle is covering distance ds, dx distance covered with velocity u, and dy distance covered with velocity v, and dz along z direction velocity covered with w. So these are three components of velocity responsible for covering traversing distance dx with velocity u, dy with velocity v, and dz with velocity w. And time interval remains same. So time interval remains same. Dt remains same. Dt equal to dx upon u equal to dy upon v equal to dz upon w. This is equation of streamline by using the combination 1, 2 and 3. First combination D, this one and this, then combination either 2 and 3 or 1 and 3. You can solve this equation and find out the equation of streamline putting conditions of the fluid particle that are given in the question. So now we are going to solve one question to make understand how this remains constant. This remains constant. That is a time interval dt. In dt time interval covering distance dx with velocity u. So time interval remains constant for covering distance dx, dy and dz. So there is a question that I want to solve. So this question is, the velocity distribution for a three-dimensional flow field is given by v equal to axi plus ayj plus minus 2azk, and find equation of streamline passing through position vector r equal to 2i plus 2j plus 4k. So this is here we have to find out. This is a velocity distribution of the question, velocity distribution of flow field. So by velocity distribution of flow field, we can find out. Let us make it small. So here velocity is given. V equal to axi plus ayj plus minus 2az. Okay. So here velocity u equal to ax, v equal to ay, and w equal to minus 2az. And position vector are given x, y, and z are given 2, 2, and 4. So applying equation of the streamline, here dx upon u equal to dy upon v equal to dz upon w. So dx upon u means ax equal to dy, equation number 1 and 2. First make combination of 1 and 2. dy upon v means ay. So a is constant, remove it, and integrating this equation, dx upon x equal to dy by y. Log x equal to log y, and plus here we have to make intelligent choice. How we are selecting our constant? Either we can select simple constants or log c. For simplicity, we can select log c because it can be converted as a log cy. Log x equal to log cy. So x equal to cy, x equal to cy. Now putting condition, because it is passing through 2, 2 and 4. So putting value of x and y, 2 and 2, 2 equal to c into 1, c into 1. So c equal to 1. Sorry, 2 equal to c into 2. So c equal to 1. So first equation become x equal to cy equal to 1 into y. X equal to y. This is equation number 1. X equal to y. Now choosing second combination, first and third. Not taking combination of first and third. This one equal to dx upon ax equal to dz upon minus 2az, because z w equal to minus 2az. Now we remove a and a. So again taking integration, dx by x equal to dz upon minus 2z. Taking log x equal to minus 1 by 2 log z, and plus again log, let us see another constant c dash, because already we have taken constant c. So here we are taking c dash. Now taking log x equal to log z to power minus 1 by 2 and c dash. So x equal to c dash under root z plus, sorry, yes, okay. So now putting condition here, equation number 2. Putting value of x and z here. So x equal to 2 equal to c dash upon under root z under root 4. So now here c dash equal to 2 into 2 equal to 4. So equation will become x equal to 4 upon under root z. This is equation number 2, because in first equation x equal to y, and in second equation x equal to 4 upon under root z. So combining equation 1 and 2, x equal to y equal to 4 upon under root z. So this is the equation of streamline. This is the simplest equation. This is simplest question that I have taken just to make our concept understandable to everyone, and same concept almost applied for finding out all streamline equations. And this is a very pet question for the GATE examination and Indian Engineering Service examination. And this application, this concept will be applied for finding out string function. So next topic we will discuss stream functions and then velocity potential, and combine stream function and velocity. How we can find out velocity potential with the help of stream function and stream function with the help of velocity, velocity potential. And then we go for the defining continuity equation for one or two dimensional and three dimensional, and also we will define circulation, vorticity, and rotation vector. All these things we are going to discuss in kinematics of fluid. So this topic is going to become very, very interesting and very fruitful from the competitive examination point of view. I think you will certainly enjoy it, and like and subscribe it and giving your time and for watching my video. Thank you very much and have a nice day. Thank you.